Now we have seen that why we want to solve system of linear equations. And answer is that there are many applications in machine learning, right? So that is why we want to solve system of linear equations, because it can solve real world problem. Now let's just see that what else we need to study in this particular topic. So see, this system of linear equations, this is a major topic in GATE. In linear algebra, there are only two major topics, which is system of linear equation and eigenvalues and eigenvectors. Okay, these are the two major topics, and yes, there is also one important topic, which is determinant. So determinant is also one important topic, but I can say as a major topic, you can consider these two, or if you want to include determinant, then these three are major topics, right? So first topic that we are going to study, which is first major topic in the linear algebra, is the system of linear equations. So let's just first see that what are we are going to study in this system of linear equation. First, we will see that why you want to solve system of linear equations. I think that is covered, which means now you know why you want to solve system of linear equations, right? Even you do not know, that's perfectly fine. Like, we want to solve it because that's in the GATE syllabus. Now, in today's video, we are going to see a geometric interpretation of system of linear equation, and then after that, we will see that how we can understand this system of linear equation, which is actually Ax equal to b, intuitively, and finding the number of solution. So just be with me, and then you will understand this Ax equal to b in the most intuitive fashion that is ever possible. Okay, so this Ax equal to b can be understood intuitively also, and that's where, like, if you go to the interviews or if you go to any good place, then they will ask the question from the intuition behind the Ax equal to b, right? And that's where we will be covering in a quite depth with many examples. And then we will see the proper step-by-step method to find the solution for X equal to b, which means there is a method called Gaussian elimination, and this method is actually one step-by-step procedure to find the solution for X equal to b. So if by chance, if you do not understand this intuition, or you do not understand this geometric interpretation, or this, by chance you do not understand any of these three, then if you just understand this last thing, that how to solve step by step using some procedure, then you will be able to achieve, like I can say that, full marks in the GATE from this topic. If you just understand this particular point, which means how to solve given question step by step. But that's also important to understand this intuitively. Reason being is that either it will be useful in the question, you will be having feelings toward the subject, or either you will be using that in the question, or you will be using that the same intuition in the interviews. So that's why we will be seeing this intuitively also. Okay, so let's go to the next point, which is geometric interpretation. So like we have already covered that why we want to solve system of linear equation. Now let's just see the geometric interpretation behind this system of linear equations, right? So suppose that these system of linear equations are given to you. Now, first what we want to do, we want to write the system of linear equation in the form of Ax equal to b, which means what we are going to do, we are taking out the coefficients. So here the coefficient is 1, and this is 2, this is 3. So we are writing this 1, 2, 3 here, and the next coefficients are 2, 5, 2. Then we are writing these coefficients here, and the next coefficients are 6, -3, and then 1. So we are writing these coefficients here. So basically, we are writing the coefficients, and then we are writing x, y, z. And whatever is on the right hand side, which is 6, 4, 2, we are writing 6, 4, 2 here. So my claim is that this representation and this representation both are same. Let's just check it if both are same or not. See, if we just multiply this 1, 2, 3 with x, y, z, then what you will be getting? You will be getting 1x into 2y plus 3z, and then that is the first index, which is 6. Then you will be getting equal to 6. So basically, if you just multiply this 1, 2, 3 by x, y, z, then you will be getting this particular equation, and which is equal to 6, right? And similarly, if you multiply this with this, you will be getting the second equation, and similarly you multiply the third row with this column, which is x, y, z, then you will be getting this last equation. So basically, we are going to represent this equation format in the matrix format, and then we will be applying some linear algebra tools. So that is first thing that we will be doing. We will be representing this equation in the this set of equation in the matrix format. I hope that is okay to everyone. So just to recall you that this matrix format, the multiplication you can do either this way, or we have very nice way of multiplication. So let me just quickly recall you, because that's where the whole of this Ax equal to b will revolve around. Okay, so that's why let me quickly recall you. See, suppose this is given to you, then what you will say, that 0 times of the first column, 0 times of the second column, and 2 times of the third column should be the answer. So 2 times of the third column will be the answer, which is 6, 4, 2, right? So that's how you can understand that how to multiply a matrix and a vector. We have already covered it. Now let's just give one more example. It is saying 4 times of the first column, 5 times of the second column. Since it is 0, so it doesn't matter. 6 times of the third column. So that's why it is also 0. So that's why only the 4 times of the first column will be the answer. Right? Very easy multiplication. Now, yeah. Now let's just multiply this 4 times the first column, 5 times the second column, and 6 times the third column. So if you do this, then you will be getting 4, 5, 6 as an answer. Right? Okay, anyway, this is identity matrix. So I will cover this later. This is identity matrix, and if you multiply identity matrix with something, then you will be getting the same vector. Now, coming back to the system of linear equation. So this will be given to us. I mean, they will ask us to solve this. Then what we will do, we will rewrite this set of equations in the matrix format. I hope this matrix equation is clear to everyone. So basically, we will say that this is nothing but Ax equal to B. And just for our understanding purpose, we may also understand this Ax equal to B like this also, which means we will say it is X times first column and by times second column. This is what we can do for our understanding. Okay, for our understanding, we can do this also. And this is actually very useful. This kind of understanding will be very useful for Ax equal to B. So it like all the dots will get connected. Just be with me. And like now you will you might say that okay, why we are understanding. I mean now what we are inferring from this kind of interpretation. Like all of these dots will get connected. Don't worry. So for now, just understand that if they give you this, then first of all we will write as Ax equal to B, and then we will do anything, right? So for intuitive purpose, we may also understand this Ax equal to B as like this also, right? So this we may do for our intuition. Cool. Now, just to summarize that given this, what we will be doing, we will be rewriting this as this, which means we will be rewriting the system of linear equation as a Ax equal to B. I hope that is fine to everyone. And this is called coefficient matrix because I am taking out the coefficients. So this is called coefficient matrix. So what we are going to do, given this, we will write as Ax equal to B. Okay, cool. Now let's just see the geometric interpretation of Ax equal to B. Can we understand this Ax equal to B geometrically? Let's just see. So suppose that Ax equal to B is given. So for now, I'm writing this Ax equal to B as a linear combination of columns. As you know that we can do it, right? See, suppose this Ax equal to B is given, which is something like this, which is basically 1, 3, minus 2, 2, and then xy, which is equal to 1, 11, right? Now we can write this Ax equal to B as a linear combination of columns. That's what we can do for our understanding. So basically, when I am saying the geometric interpretation, then there are two types of interpretation that you can do. One is called column picture. So currently I'm in the first kind of interpretation where I will be interpreting this Ax equal to B as just columns, which means I can understand this Ax equal to B as like this, which means as a column picture. So what do I mean by that? It means that geometrically it means that there are two columns, 1, 3, and minus 2, 2, whose linear combination should give you 111, right? So let me tell you what do I mean by that. See, this is called column picture. It means first column was 1, 3, right? Maybe I can go to the next page and let me show you what do I mean by that. So see, this is your first column, which is 1, 3, and the second column which you have is minus 2, 2, right? That's what we had. See, this is what we had. Let me also copy this. Okay, so this is 1, 3, another column was minus 2, 2, and these are the two columns. And what I'm saying is that some linear combination of 1, 3 and minus 2, 2 should give me 111. How can I interpret this geometrically? It means there are two columns. First column is this one, first column is this one, and geometrically it looks like this. And second column is this one, and geometrically it looks like this. And what we can do, we can have a linear combination of these two. So can you tell me the answer? Like we will calculate the answer little later, but intuitively or maybe by hit and trial, maybe the answer is here 3 into 1, right? 3 and 1. So maybe x equal to 3 is the answer. Here you can write 3 and here you can write 1, right? So 3 into this column and 1 into this column will give you 111. Can you check it? 3 into 1 will be 3, minus 2 will be 1, 9 plus 2 will be 11. Yes, so this is the answer, right? So what do I mean by that? These are the two columns, and now first column times 3 and second column times 1 gives you this. So here what I'm going to do, first column times 3, so this will be the another column, and then a second column times 1. If you just add these two, you are going to get 111, right? You are going to get 111. So that's what the geometric interpretation means. So currently you might not be agreeing that it is so intuitive or not, but slowly you will get to understand that this is the most intuitive geometric explanation that we can give to you. Okay, so I hope you understood this geometric interpretation 1. So here what we are going to do, given this ax equal to b, we are going to think about the columns that we have. So we are going to think about the linear combination of the columns. This is what geometric interpretation 1 says, which means we are going to think about the column picture. So this is the column picture. Okay. Now let's just see another picture which is called row picture, which means now let's just talk about the geometric interpretation 2. Now again, given this, okay, so here given this ax equal to b, what we are going to do in this interpretation, in the geometric interpretation 2, we are going to have, let's suppose that this is given to you. Now we are going to have this as a, not as a column picture but as a row picture. So what we are going to do, we are going to say that okay, this can be written as x minus 2y equal to 1, and then 3x plus 2y equal to 11. This can be written something like this, which means that if the ax equal to b is given to you, then you can write this ax equal to b as something like this, right? This is the another geometric interpretation that I want to have. So see, earlier I was saying that I can write, let me just copy this. So see, earlier I was saying that I can write this ax equal to b as something like this. Now I'm saying that currently I'm interested to write this ax equal to b as something like this, which means these are the three things that we had. Now instead of this column picture, I want to have a row picture, which means I want to write this ax equal to b as something like this. Then let's just see if I can interpret this geometrically. So this is done. This is called column picture. This is called row picture. Now let's just see if I can interpret it, like if I can understand this row picture or not. So what we are going to do, we are going to have two equations, two unknown in this row picture. Then what we are going to do, we are going to plot this on the graph, which means these are the two lines currently, right? So these are the two lines. So what I'm going to do, I'm going to plot these two lines, and then finally the answer will be this intersection point. Earlier, if you remember, the answer was 3 and 1. Now also answer is 3, 1. Which means the earlier answer, whatever it was, this is 3 and then 1. Whatever it was the answer, here also the answer is same. Answer won't change. It is just the way of interpretation. So we have two interpretation currently. One is the column picture, where you are seeing this ax equal to b as a linear combination of columns. See, this is ax equal to b, and you are seeing this ax equal to b as a linear combination of columns. So this is just one picture. Another is that given this ax equal to b, you are seeing this as a rows, which means you are seeing this as an equations. So you don't have the column picture. So column picture is the geometric interpretation 1, but here you have the row picture. So this is called row picture. In the row picture, what I will do, I will plot these two equations, and then I will say that whatever is the intersection point, it is my answer. Now this interpretation is called row picture. Now obviously the common question is that which interpretation do you like? Do you like the row picture or the column picture? What do you think? So we had the two pictures. Now my question is that which interpretation do you like? Just give me the answer. What do you think? So you might say these are the two pictures that we have. You might say that you like column picture, or you might say you like row picture, right? You might say one of them. But just let me know that what is your answer. I mean, what do you think? Which picture is preferred to you? Do you want to understand this ax equal to b like this, which means linear combination of columns, or like this? Now currently you may say that row picture is better because it is giving you more intuition that okay, these are the two lines meeting at particular point. Now let me just tell you that row picture is just better for only two equations. For only the equations which are having just two variables, x and y. But it is not better for multiple variables. Let me show you how. Suppose you have multiple variables, right? Now this means row picture will say that row picture will shows that three planes meeting at the single point. Now let's just see. So suppose these are the three planes. I think 1, 2. These are the two planes meeting at this line, and this line is meeting at this plane, and finally you have this answer, right? So if you have row picture, then you need to visualize in terms of the plane. Okay, and that is obviously impossible. You can't visualize the planes, right? So you can't visualize more than 2D. You can't visualize anything which is more than 3D, right? Even more than 2D is not possible to visualize. So visualizing these three planes, like once these two planes are intersecting on one line and then this line and this plane are intersecting, it is very, very cumbersome. So that is why we will move to the column picture. Now let's just see this column picture. Here we have these two columns, right? These are the two columns that we have, and then finally we are saying that this third column that we are getting, which is 642, is basically a linear combination of these two columns. Sorry, these are the three columns that we have. So in this particular case, in this example, we have the three columns, which are 1 2 6, 2 5 3, 2 5 minus 3, and 3 2 1. So 1 2 6, 2 5 minus 3, and 3 2 1. So these are the three columns that we have. Now what we are saying here is that whatever we are getting, this which is 642, is basically a linear combination of these three columns, right? So the coefficients here are 0 0 and 2, which means just 2 times of this column is getting you this, and you do not need this and this column. So that's the idea, right? So basically these are the three columns that we have, and that then this right hand side can be obtained by the linear combination of these three columns. Now is it easy or is it good to visualize like this way? Now here also you can say that it is not very easy to visualize, but comparatively I can say it is better than the previous case, right? So here you just need to check the directions of the vectors. Yes, see, in the 2D you cannot plot the 3D vectors, which means that this 1 to 6 will be basically like it will be pointing towards you. I mean, you cannot draw a 3D vector in a 2D. That I completely agree, but still it is better than the previous case. Anyway, let's end this debate here. So for our purpose, what we will be doing, we will be actually utilizing this column picture, which means we will be saying that right hand side is a linear combination of the columns, which means I will be saying, see, something like this, that right hand side 111 is a linear combination of these columns, and actually the all of this Ax equal to b will be just based on this column picture, I mean, for our purpose. Okay, so we will be dealing with the column picture only. So we will be saying whenever Ax equal to b is given to you, then just convert that Ax equal to b to column picture if needed, which means just assume that right hand side, not just assume, just treat it like this, that right hand side 111 is a column, is a linear combination of these two columns, which are 1 3 and minus 2 and 2, right? But yeah, if it is just a 2D, then you can visualize it using a row picture also. I mean, that's perfectly fine if it is these are just lines, but more than lines, if it is a plane or something, then it is not easy to visualize, right? Okay, now let's move to a next question, which is that do we always have a solution of X equal to b? Which means, can we always solve X equal to b? That's very, very interesting question, right? So I can say it is very interesting question, that can we always solve Ax equal to b? Let's just see the answer. So suppose we have three examples here. This is first example, this is second example, this is third example. And now in these three examples, using these are like toy examples. Toy examples means very, very small examples. We will try to see that can we always have solution or not. So let's see the example 1, which is actually a case 1 where we have the unique solution. Which means if you have these two equations, then these two lines are meeting at this point. So you can visualize as a column picture also, which means these are the two columns which are 1 and minus 1, and this is the column which is minus 2 and 3. They are basically producing this 1 and 3, which means that you can say, like, I mean, if you want, you can visualize as a column picture. Actually, visualization is not much important, but yeah, still let me just visualize. So basically 1 is 1 minus 1. So maybe first column is this, and which is 1 minus 1. Second column is minus 2 and 3. Maybe the second column will be something like this, minus 2 and 3. And then can you get 1 and 3, which means can you get this column, which is somewhere here, 1 and 3 from these two columns. So there must be the coefficients, right? I mean, you can see you can see here these are meeting at one point. So whatever is the answer in the column picture, in the row picture, the same answer will be in the row picture, or the column picture basically. So basically this interpretation is not important, but what I'm saying here is that given the set of equations, you have the solution, and there is just one solution, that is called the unique solution, right? That is called the unique solution. So see, these two lines are meeting, so this is the unique solution that we have. Now let's just see if we can have no solution also, which means suppose the set of equations are given to you, are they like, is this possible that they are not meeting at any point? Yes, that's definitely possible. For example, this. So basically, what kind of examples are there? See, suppose you have x plus y equal to 3. This is one equation. And another equation is that x plus y is equal to 5. If these are the two equations, then since these two equations are not agreeing to each other, you put whatever value of x and y you want to put. These are not even agreeing to each other, right? So you put whatever value you want to put for x and y. It doesn't matter, because these two equations cannot be satisfied simultaneously. So that is why there is no solution, because these two equations are not even agreeing to each other. Similarly, this is happening here, that these two equations are not even agreeing to each other. Here x minus x1 minus 2x2 equal to -1. But here, if you just multiply by -1, this is x1 minus 2x2 is -3. It is actually like first equation is saying -1, second equation is saying -3. So basically these two equations are never going to meet each other. So that's why there is no solution. So yeah, there are cases where the no solution also exists. So don't worry, we will see in the more elaborate fashion. But today we are currently just covering, I mean in this video we are just currently covering just a basic idea that yes, what kind of solutions are possible given the system of linear equations. So unique solutions possible, no solution possible, and similarly there is third case which is infinite solutions also. Which means if multiple equations are given to you, then you will say that okay, there are infinite number of solutions are also possible. Which means like, see, this is the first equation here, this is the second equation here. Now if you see, these two equations are actually same, which means they have just given you one equation. This equation can be obtained by -1 into the first equation. See, let's assume there is one equation, x plus y equal to 5. There is another equation that they give you 2x plus 2y equal to 10. Actually these two equations are same, and then they ask you how many solutions are possible for these two equations. Actually these two equations are nothing but just a one equation first of all. So you will just remove this particular equation, and then you will answer the question that how many solutions are possible for this equation. So if you want to satisfy x plus y equal to 5, so for every value of x you have the y, which means if x is let's suppose 1, then y will be I think 4. If x is 2, y will be 3. If x is -1, y will be I think 6, like that, right? So basically there are multiple solutions possible. First solution you can say is 1, 4. I mean 1, 4 is satisfying, definitely. Similarly 2, 3 is also satisfying these set of equations. I mean although these are two set of equations, but essentially it is just one. -1 and 6 is also satisfying. So there are infinitely possible solutions. In general there is something called parametric form. So you will say if x equal to k, then y will be 5 minus k. So you will say that k comma 5 minus k is also satisfying. So that's called parametric form. Parametric form means there is some parameter, something like k or something. For every value of k, you have 5 minus k, right? So anyway, like there are infinite solutions also possible. You can visualize in the column way also. Let's just try visualizing. See, this is 1 minus 1. This is -2, 2. And then they're asking, is there a linear combination of these two such that you get -1, 1? Then probably there are multiple solutions. You can say you multiply -1 here, 0 here. Then there is then this actually satisfy, I think, right? -1 here and then 0 here. Yes, this satisfy, right? Now can you have other solutions? Maybe you can say -1/2 here, -1/2 here, or maybe +1/2, I think, +1/2 here, 0 here, then also it satisfy. So basically there could be infinite number of solutions. Either you understand using row way or column way, does not matter. But actually for our purpose we will just prefer column way. Okay. So till now what we have just seen is basically there are little bit definitions of system of linear equation, and most importantly we have just seen that we can represent this system of linear equation as ax equal to b, just like this. So the system of linear equation can be represented as ax equal to b, and we can interpret this as a column way, which means this ax equal to b is nothing but a linear combination of columns of a. See, these are the columns of a, right? And this ax is nothing but a linear combination of columns of a. So we will be using this kind of intuition to solve questions. So now we are in the next video, and we are actually going to build some basics. We are actually going to solve many questions, so that it actually fit into your mind, such that even in the subconscious mind it doesn't get removed. Which means like if someone asks you in the sleep also, if you're sleeping and someone just wake you up and then they ask you intuition about x equal to b, you will just answer it. We will make sure that you understand this to that level. Okay. So let's just continue in the next video, and then you will get to understand this ax equal to b in the most intuitive way that could ever possible. Okay, thank you so much.